So we're going to be talking about the graphs of the polynomials now, and we've talked a little bit about it with the number of turning points that there are and the end behavior. And if you're looking at this one, this is both ending up, so because they're both the same way, it's an even degree, and because they're both going up, the leading coefficient is positive. And it has 3 turns, which means it's a quartic, actually. And we're going to find some other parts to the graphs here and learn about other parts to the graph. First, the relative minimum and maximum. Just like the other min and max, it's where the graph turns, except it's not necessarily the highest point or the lowest point. So we're going to write it as the coordinate, not just the y value now. So my min here is going to be these 2 points. There's 2 of them. There's 2 relative minimums. So those 2 points at negative 0.43, negative 2.83, and the other relative minimum 1.7, negative 0.4. So those are my relative mins, and I have a relative max where the graph is turning this way. So the relative mins, the graph turns this way. The relative max, the graph turns this way, which is going to be right here at the point 1, 0. We're also going to learn about the increasing and decreasing intervals. And you're talking about from left to right, where is the graph increasing or decreasing? So those are referring to the y values. Where is the y values getting larger? Where are the y values getting smaller? You're going to describe that using the x values, okay? So if I start on the left side and I trace the graph, I'm going down. So from this point, which is negative infinity, all the way to this point, the graph is decreasing. The y value is decreasing. So you're using your x value, you're using your x values in the intervals. So it means from negative infinity all the way up to when x is at negative 0.43, the graph is decreasing. And then it turns and it starts going back up. So it's going to be increasing from negative 0.43 all the way to where x is 1. And then it's going to decrease again. It's going to be going down again. So it's going from 1 to where x is 1.7, where it decreases. And so if you're having trouble sticking with me here, understand I'm trying to, if I trace the graph from left to right, it's going down, which is a decreasing interval from negative infinity all the way to where x is negative 0.43. And then the graph turns and goes up. And I'm going up or increasing from that x value, negative 0.43, all the way to where x is 1. And then I'm decreasing again from between 1 and 1.7. And then now it's going to increase again from 1.7 all the way until infinity. So now we're going to learn about the multiplicities of the graphs. You can also tell multiplicities from the graph, which is going to occur where the graph turns on the x-axis. You have a minimum or a maximum on the x-axis, basically. So I'm going to start with a new graph to show what the multiplicities look like with different types. And it's really, you can tell whether it's even or odd. In our case, if there's a multiplicity and it's even, we're going to use it as a multiplicity of 2. If it's odd, we're going to use it as a multiplicity of 3. And then we're not going to go any further than that. But in actuality, you could have more and it just looks even or looks odd. So what the graph does when it's even, is it will hit the x-axis and turn back the other way. And it will look similar to a parabola, okay, for that section of it where it hits it, touches it, and turns back. The odd makes really kind of two turns on the x-axis and goes through. An odd degree will go through the x-axis where it kind of turns like this and then turns again and goes up this way. This is similar to a cubic graph where it makes that little S turn, and that's what I call it. You won't hear that anywhere else, but it goes through it and looks kind of like an S and makes that S turn where it looks similar to this. So this would be a x equals 5 with a multiplicity of 3. And this would be x equals -5 with a multiplicity of 2. So because this one turns right here, I have a multiplicity of 2 at x equals 1. Okay, a couple more things we can do here. The domain for the polynomials is always going to be all real numbers. We're going to start writing this in as intervals as well, though. Okay, so the interval for all real numbers is going to be from -infinity to positive infinity, and that's referring to all real numbers. The range in this case is going to be the y values, which are going up to infinity, but they don't go down to -infinity. It stops at this point, which my lowest point on the graph is at -2.3. And I'm sorry, -2.83. If you're writing with inequality, it's going to be y is greater than or equal to -2.83, because all the y values are going to be greater than that -2.83. The interval notation, you want to go from the lower value to the higher value. So the lowest value on the graph is -2.83 to positive infinity. Well, there's one thing I need to change here. I'm not going to have parentheses on. It does hit exactly at -2.83, so you put a bracket to express that equal to. The bracket is representing the equal to part on the interval. And the last part is to write the polynomial in factored form. Well, I can do that from the zeros of the polynomial. Assuming that there aren't any imaginary zeros, I can write the polynomial from the zeros that I have. So I have a 0 at -1, +2, and +1, but remember the +1 is with a multiplicity of 2. So to write it in factored form, I have x plus 1, x minus 2, and x minus 1, and that's going to be squared. And this is the factored form of this polynomial graph. Okay, so we're going to do two examples of sketching a graph of a polynomial. Go ahead and pause it, write the steps down, and draw a graph, and I'll get back to graphing this one. We're first going to write it in factored form, which this one is already done. Now we need to find the zeros. So for this one, my zeros are going to be -5, +3, -2, and don't forget this x out in front is going to be 0. Find the y-intercept. Well, to find the y-intercept, remember you always can plug in 0 for x. We're going to plot the zeros and then the y-intercept, determine the end behavior, so where the arrow's going on the ends, and then basically connect the dots after that with the arrows and all the turns and everything like that. So I have my zeros. To find my y-intercept, if I plug 0 in for x, that's going to make this one 2. That's going to be 0 plus 2. This one's going to be 0 minus 3, so that's going to be -3, +5. And then this x out in front, well, it doesn't matter what any of these are, if I have an x out in front, there's going to be a y-intercept of 0. So that's going to be my y-intercept. Plot my other zeros. I have at -5, +3, and -2. So these are my zeros. My y-intercept is that origin, and I need to determine the end behavior. You don't have to multiply everything out. All I'm concerned with is that first term of the standard form of the polynomial, which is going to come from just multiplying all of these. So determining how many x's are being multiplied, that's going to give you your degree. So I have 4, which is going to be a quartic. And because all of these are positive, and then this one is negative, that means my leading coefficient is going to be negative. So this is even with a negative leading coefficient, means that they're both going to be going the same way and they're both going to be going down. So what I want to happen is from this last 0 on the left side, the graph's going to be going down. From this last 0 on the right side, the graph is going to be going down. And then from there, I'm going to have the curves and connect them. We're not going to be specific with the maximums and minimums. It will just take a lot longer. You could plug in points in between here and find and be more specific where the graph is increasing, where it's decreasing. But we're just going to kind of sketch a graph from here. Which is why this isn't completely accurate, but it is a quick sketch of the polynomial. And that's it. Okay, one more. So I have this polynomial here. And what I'm going to do is I first need to factor this quadratic part and write that in factored form. Well, this is one of the easier ones. What multiplies before the adds to before, it ends up being x plus 2 times x plus 2, which is x plus 2 squared. So my zeros are x equals +1, and then this is going to be -2 with a multiplicity of 2. And I have the y-intercept. I'm going to plug in 0. So I have y equals 0 minus 1. And then I can plug in 0 here in the factored form. That's going to be 2 squared. So 2 squared is 4 times -1 is -4. So my y-intercept is 0, -4. Remember, I plugged in the 0 for x, so that's the x value of the y-intercept. So I'm going to plot my zeros. +1. Let me change colors. +1. -2. Remember, I need the multiplicity of 2 right there. And my y-intercept is going to be at -4. I need to find my end behavior. Well, this is going to be an x squared here, which is this. And when I multiply it with this one, that's going to be a cubic, which is odd. So they're going in opposite directions. And they're both positive, so it's going to be a positive leading coefficient. So I have them going into a positive direction. So from this 0 all the way on the right side, the graph's going to be going up. From the 0 on the left side, the graph's going to be going down. Remember, there's a multiplicity here, so it does that multiplicity of 2 turn.